Alright, what can I do? I feel like I've waited 7 seconds. No, I want there to be questions. Alright, so they're telling me this. F of g of x equals x. What does that mean? Why did they tell us that? What are they giving us there? F and f g are inverses because if I take x and plug it into g and then that results into f, they cancel each other out and I end up back where I started. So they're asking me for g prime, like if I look through those answers, they're all g prime. But the information they gave me is all in f's, so I'm not going to use g prime, I'm going to call it f inverse. So like f of f inverse of x equals x, so I'm just saying g and f inverse are the same. So the derivative of f inverse prime is 1 over f prime of f inverse of whatever. So it's kind of like A or B in this case. If you look at the answers, they gave you some that are g prime of A. And remember, g prime is the same as f inverse prime. They give you some that are g prime of A and some that are g prime of B. But remember, our job is to find the inverse. So, like if it's g prime of B, B is, my first job would be to find f inverse of B and then plug into the derivative. So, this tells me the original point. If I want to find the inverse of B, can I do it? Like, what letter is the inverse of B? Sort of expecting a response there. So, I just don't know whether to put that there. I don't know whether to do this or this. Is what I'm trying to figure out. So my first job is like, because this is an inverse, is this the y value or the x value? Because it's an inverse, that's the y value. So to find the inverse of b, I would look for the x value, right? So if I start with b and look for the inverse, can I find it? Yeah, it's A. Well, if I started with A, like if I thought it was this way, if I started with A, I look for the inverse. Can I find it? I cannot. It would have to tell me like f of something equals A, so I can start with A and go back to whatever that is. But it doesn't tell me that. So I cannot find f inverse of A. Which means it cannot be A or B. Because those used A when you plugged in. So I'm going to plug in B. So 1 over f prime of f inverse of B. So f inverse of B is like, look at the point and take the, this, they're giving you the y value, it's inverse, take the x value. So this is now 1 over f prime of A. And then you'll notice it kind of lines up with the problem because they just told you what f prime of A is. F prime of A is C. So we just showed that f inverse prime of A is 1 over C of B. Which means G inverse G prime of B is 1 over C. Because f prime and G, f inverse and G are the same thing. How'd that go? Okay. What else? That one I thought was the hardest one. But I'm happy to do all of them, any of them, whatever. Yeah, did someone say 22? It's not 22. 6, they give me this, but I don't like those radical signs. I don't want those. So I'm going to rewrite that as powers. So this would be 1 plus x to the 1 half, all to the 1 half. Agree? So then I've got a chain rule. So my big guy is this 1 half. So I take the derivative of the big guy first. So the way I take the derivative of the power is to bring it down and reduce by 1. And the little guy gets left alone, right? So 1 plus x to the 1 half goes in here. Then the chain rule piece is I multiply by the derivative of this little guy. So I multiply by the derivative of 1 plus x to the 1 half. The derivative of 1 just nothing. The derivative of x to the 1 half, you bring down the power, leave the x, and reduce the power by 1, so now it's negative 1 half. Like, that's the correct answer. It's just not how they put it. They put it back into a fraction form. So let's look at how we would do that to match up. So I've got 1 over 2 times 1 plus x to the 1 half to the 1 half. So I'm just taking this 1 over 2 that establishes a fraction, and then I'm taking this piece and just flipping it down to the bottom. Times, again, 1 over 2 establishes a fraction there, and then this x to the negative 1 half, because that is a negative exponent, I'm going to put it on the bottom. Just looking at their answers, there are no negative exponents, so this must want me to get rid of those. And then I'm going to multiply across here. So 1 times 1 on top is 1. The bottom, we get 2 times 2 is 4. Then we've got the x to the 1 half. And then we've got the 1 plus x to the 1 half to the 1 half. And then they just put it back into, I think you can probably tell from there, that they just put it back into like square root notation. Something like that. But it's d. Freeze thumbs up. You right? What else? So those are the 2 I thought were the hardest. 7. All right. So we're looking for how many points where the tangent line is horizontal. That's one of the things you definitely have to know, how to find a horizontal tangent line. This doesn't ask you to find it, but it asks how many there are. So if the tangent line is horizontal, what do we know about the slope? It's 0. So what do we know about the derivative? It's 0. So we want to take the derivative, set it equal to 0. This derivative has the x's and y's mixed up. It doesn't explicitly say y equals blah. It's like they're both in there, so we're going to have to use the implicit differentiation. The derivative of x squared is 2x. The derivative of 4y squared would be 8y, but I took the derivative of a y, so multiply by dy dx. And then don't forget to take the derivative of the right-hand side also, and that is 0. And then I want to solve this for dy dx. So I think I would subtract 2x from both sides. And then divide by that 8y. So I get dy dx equals negative 2x over 8y, or if you wanted to reduce it, it's negative x over 4y. I don't think it's any real benefit to doing it in this case, but you can. So if I want the derivative to equal 0, a fraction equals 0 when the top equals 0, right? Like I got $0, I can divide it by however many people I want. Everybody's getting $0. Undefined comes when the bottom equals 0. And that's a vertical tangent line. So horizontal tangent line, we want to set the top equal to 0. So negative x equals 0. So that just tells me x equals 0, right? So like divide by negative 1. Have I answered their question yet? Have I answered how many horizontal tangent lines there are? Like, it's kind of tempting to think you're done because you like did a thing and you're like, hey, I got 0. But that is not a horizontal tangent line. It's an x value. Horizontal tangent lines have to be y equals a number. So to find the y value, I'm going to have to plug back into this. I'm going to plug 0 in for x and find out the y values when x is 0. So it'll be like 0 squared plus 4y squared equals 16. So there is a tangent line, or there are tangent lines. We don't know yet. When x equals 0. So let's plug it in and find out. Then we divide by 4. So y squared equals 4. And if I solve that, how many solutions are there? 2. And those would be the equations of your tangent lines. Would be the positive y equals 2 and y equals negative 2. Remember, it's an equation of a tangent line. Don't just tell me like 2 and negative 2. Also, if I had asked you for a vertical tangent line, you would have just done like the complete opposite. So vertical tangent line, the slope is undefined, which means you would set the bottom equal to 0. Well, when you solve that, you would get y equals 0, and you have to plug back in to find the x value. So it's the same process, just like reversed. Someone back there said 7, right? Is that good? Okay. Others? Just curious question. If you, let's say, I'm going to do number 10 right now, right? Let's say you did it and you got it. Is it still valuable to watch someone go through it? That's still pretty helpful, right? So 10 sine inverse of x plus, I'm just going to make that 2x to the 1/2 instead of 2 square root of x. Is that fine, Max? Okay. So sine inverse. You guys all memorize these, right? What's the derivative of sine inverse? They're all 1 over. I know it's positive because it doesn't start with a c. What else we got? Root 1 minus x squared. And in this case, the x is literally just an x. So it's like 1 minus blah squared. So when I don't really have to do the chain rule. I can, but like, what's the derivative of the thing I plugged in? It's just 1, so I'd be multiplied by 1, which doesn't really do anything. Plus, then I do the power rule over here, so bring down the 1/2 times the 2 is just 1, and then reduce the power by 1. And then line it up with their answers, so all they did was they just got rid of that negative exponent. So it would look like that, which is, but if you look at E, it is 1 over the square root of x squared minus 1 plus. So that's all that's doing is flipping those around. I did that in class the day before. It's real easy to do. They're going to try to trap you on it. You got to know those like really well. Max, how's that for 10? What else? They're going to do like 10 in this class. Yeah, negative. Okay, so f of x, give me g of x is the inverse function, and that's what we're looking for. But the whole problem's in f's, so I know g of x is an inverse. But I'm going to use f inverse of x is the same. So, like, they gave me f and g, but I want the problem all to be in the same letter. So I don't want the g's in there. So I'm going to use f prime instead. And we know the derivative of f inverse, so f inverse prime, is 1 over f prime of f inverse, and then they give me a number here of 0. So that's just the formula. Like, you kind of have to know that, or you have to know how to get to it. I showed you like the way it came from chain rule yesterday. So that's an option, but otherwise you got to memorize it and then know how to use it too, right? So typically this would be the x value. I'd ask you for the y, but because this is inverse, this is the y, and I'm asking you for the question, f of 2 equals 0, they're giving you the y and asking you for the x. So when I plug in 0 into the inverse, I get 2. So then this is 1 over f prime of 2. And then I know f is up there as that guy, so I just take the derivative of that. So 3x squared minus 2. If I plug 2 into that, 2 squared is 4, times 3 is 12, minus 2 is 10. And then I made this mistake yesterday too, don't be me. But you gotta put a 1 under that, or over that, because we're working with the bottom. So it's 110. Who was that you? How'd that go? Good. Okay, let's go on. Turn to 3-5. 3-6. Sorry. I can do calculus. So this is what I was telling you about the other day. You're gonna have to find like the second derivative, the third derivative, the 12th derivative, whatever. So this is just different ways to notate it. Y prime, 2 primes, 3 primes, f prime of x, 2 primes, 3 primes, and you got the d and the y. So I'm gonna do a couple of them. I'm gonna give you like a challenge, show you one thing, and then I'll let you go. So this is literally just taking the derivative over and over and over and over until you're done with what it says. Sometimes they're just very straightforward. So this would just be 6x to the 5th minus 8x to the 3rd plus 10x minus 3. I know you guys know how to do this. I'm just going through it. So then take the derivative of that. So it'd be 30x to the 4th minus 24x squared plus 10. Then take the derivative of that. So 120x to the 3rd minus 48x. What? Max, did you say something? Someone said something. Now take the derivative of that. So 360 x squared minus 48. This doesn't work with everything, because like sine, cosine, for example, just go back and forth. But if I kept going in this, any polynomial like this, if I just keep going, what will I have to end up with eventually? 0. Because eventually this is going to be an x squared, then it's an x, and then it just like eventually disappears. Sine, cosine don't work that way, because you just bounce back and forth. But some of these do. Try the second one. Don't worry about a common denominator. I don't want to worry about that right now. Just do like each term separately. I'll rewrite it first. Let's get rid of the radical. And then just take the derivative of each of those, so that becomes 1 half x to the negative 1 half minus 2x to the negative 3. And I said don't worry about common denominators, so we just go again. So negative 1/4 x to the negative 3 halves plus 6x to the negative 4. If we keep going for eternity on this, will we reach 0? We won't. So they're not all like that, right? That one was, that one's not. If I integrate it, I get 0. But you wouldn't get. So if I add to the power, though, I'm not going to get 0 there either. 40th derivative, and I do not want you to take the derivative 40 times. I can make that 400 to be the same. So there's, don't take the derivative 40 times. Figure out a different way. So I'm going to make it 5 million, so you want to do it? Stop. Without doing 40 derivatives. That would be really nice. 40 is nothing. Okay, so y equals sine of x. Y prime, first derivative, cosine of x. Y double prime, second derivative, negative sine of x, right? We flip to negative. Third derivative, negative cosine of x. Fourth derivative, sine of x. So aren't you right back where you started? So that's the 0th derivative, first, second, third, fourth. So then, it'd be the 5th, 6th, 7th, 8th. No, that's not how it goes. 5th, 6th, 7th, 8th. So which one's the 40th? Sine of x. You would just do this like 10 more times. Is that okay? Okay. So let's do the one in your book there. That second derivative with implicit differentiation. We did this on that half day. I showed you a couple where you gotta like plug back into the original. Let's do more. So that's what I'm supposed to find, and they gave me sine of y equals x plus y. So I know I'm supposed to do implicit differentiation kind of two ways. One, because the way they wrote this, when they do it like that, that usually is implicit. Another, the more important way, is x and y are mixed together. So I'm going to take the derivative of that. So the derivative of sine of y is cosine of y times dy dx. Because I took the derivative of a thing with a y in it, right? And then the derivative of x is 1 plus the derivative of y is 1, but let's just split dy dx. So then I want my dy dx is all on the same side. So I can solve for it, so I subtract the dy dx from both sides. But the dy dx is in 2 spots now. What do I do to get it into 1 spot? Factor? Anti-distribute? A lot of people will anti-distribute this incorrectly. They'll be like, oh, I took a dy dx out, and that was the dy dx, so there's nothing left. But there has to be a 1 there, so that if you multiply back in, you would end up with what you started. And then divide, so dy dx equals 1 over cosine of y minus 1. We good to there? But I have to take the derivative of that now. So the derivative of the left-hand side is just the d2y over dx2 thing. I have a choice. I know which one I prefer, but it is up to you. I can do quotient rule with this. I don't like quotient rule. I don't want to get fractions, but I don't have to. So I'm going to rewrite it like that. It's the same thing, right? I just brought the bottom up to the top, called it to the negative first, and then I can just use regular chain rule, which to me is easier. But there's nothing wrong with quotient. That's what you choose. So it's not my preference. So this is what I'm going to work with. Derivative of the big guy, bring down the negative 1, reduce the power by 1, so now it's negative 2. Cosine of y minus 1 is your little guy. He's just waiting his turn. Jason, I'm trying to teach, man. You just have to call him. then I multiply by the derivative of the inside, right? So the derivative of cosine of y, negative sine of y, times dy dx. So then, other questions up to there? Before I go on. The next thing's kind of like the twist, I guess. I'm going to write these without, this first part without a negative exponent. Then, I'm going to do this. That should be squared. So just make sure we know where all those things came from. I did 3 things there. So this is just like doing the derivative. And then I move the negative 2 down to the negative power down to the bottom here. Here, I just see there's fractions coming, so I'm just making that a fraction also. And then what did I do here? I know dy dx is that. So I plugged it in. I just turned it into a fraction when I plugged it in because there's 2 other fractions, and then I can just multiply straight across. But all I'm doing is substituting. And I just like rewrote the substitution part. So if I multiply straight across the top, I have sine of y, positive. If I multiply across the bottom, I have cosine of y minus 1 to the what? Third. Add 2, then I multiply by another 1 over there. Sometimes, they might actually write the answer like this. How can I do that? Plugging the original function. So the original equation told me sine of y is equal to x plus y. So this is a totally valid answer, but I can see them in the multiple choice being like a little bit extra annoying, being like, I'm gonna make sure you plug in and that x plus y is an option. How's that? Is that okay, I guess? Can I help more? You just need like time to process it. It's not like what I'm hoping here as a teacher, but I get it. On the homework, just be careful that you're not like doing way more than you need to. So look at like number 5, 6, and 7. Like make sure you know where you're starting from. Your job on 5, 6, and 7 is to find the second derivative. But do I have to take the derivative twice? No, because where are they starting? At the first derivative. So if you want the second level and you're at the first level, you just do 1 derivative. But like 8, 9, and 10, you're gonna have to do 2 derivatives. So just make sure you know like where you're starting. So this is really good practice for the gateway too, because it's having you go through all these different kinds of derivatives, do them multiple times. Like this is good derivative practice. And then tomorrow I'll give you a review. Yeah, Tuesday we practice gateway, and then we miss school. And gateway takes like 3 weeks somehow. Don't worry about the test prep. We're now done with like all the ways to take this. So then we do applications of that is a loaded project.
Oh, applications like word problems.
Well, like what do we use? then some of it is like my favorite part is like I'll give you an equation and then you can graph it for me like exactly how the graphic calculator would graph it without ever using the graphic calculator. So you can find like the peaks and valleys, you can find where it twists from like a point reflection on who that is. But asymptotes, so we'll go through and find every single thing about the equation. That's one of the applications. We like maximize and minimize. We do a little bit of physics, position acceleration stuff.
What was it?
Because I learned that the same time as I learned Avogadro's number.
Yes, I know, because it's all like, it's like a single digit number with decimals to negative 1 trillion. So,
Avocados.
it's how I always.
So not the next test. The game is kind of intimidating, I guess. So just to make you feel better. Not the next test is normal. The test after that is signal. It's really not. It's just their problems are long. So if I get to you in class, I can only give you like 2. It's not that. This is more like I just want to time test you on everything. So
But you're not going to grade that one because, man, you didn't grade ours.
it's gonna be half. I'm gonna grade it half the grade.
Oh, half. Oh.
It's not just half your class grade.
So it's
I thought it was gonna be half of our entire
I
grade.
thought that as well.
You would love that. Like the average score on this is like 49. It's not that bad.
I remember
It's not the pre-calc takeover.
that was the worst thing I